So in this video, I'm going to walk through how to construct a truth table. And so the way to start would be, what do you want to construct a truth table for? In this video, we're going to look at just trying to construct a truth table for a simple single formula. And so let's pick a formula. Our formula is going to be not P and Q. So when we look at this formula, we see that there are these operators in here. And we also see that there are two propositional letters, a P and a Q. So what we'll need to do is we will create a table, and we're going to write P over here and Q over here. So we have P, Q, and we're going to just rewrite any of the propositional letters that are found in the formulas we want to construct the table for. The next thing to do is in these columns under P and Q to write every combination of truth value that can be assigned to P and Q. So let me do that. I'm going to write true, true, false, false, true, false, true, and false. Now, these four rows are all the different ways that true and false can be assigned to P and Q. What they correspond to is what's called an interpretation. And we have at each row an interpretation. An interpretation is an assignment of a truth value to these propositional letters. Now that we have every way we can assign truth values to P and Q, the next step in building out our truth table is to, for each case of P, we'll take the truth value that is interpreted with respect to P and write it underneath P in the formula. In other words, we're going to take all the information that's found under this column and just directly write it underneath P in the formula here. So we see that P is true at row 1, and so we want to write true over here under the formula. We want to do the same thing for row 2. When we get to row 3, we see that, oh right, P is false there. So let me write false. And at row 4, P is false. So I'm going to write false again. I'm just taking this information under P and writing it under P in the formula. Now we're going to do the same thing for Q here. You see that Q is true, false, true, false. And I'm going to do the same thing. I'm going to take this column and write it under Q over there. So I'm going to write true because Q is true. Now at row 2, interpretation 2, Q is false. So I want to make sure I write false. Then we have true and false. So I'm going to write true and false. So what I've done here is I've taken this interpretation and I've assigned a truth value to the sub-formulas, the parts of this formula, P and Q. Now the next step is often the most tricky for individuals who are first starting out with truth tables, and that is, what do I do next? Now what you would do next is you would try to take these truth values that you have and use them with the valuation function associated with these operators to determine the truth value of the subformulas. In other words, you're going to write truth values underneath this negation and this sign for conjunction, and that's going to tell you, when you write it under negation, what the truth value of not P is, and when you write it under the conjunction, you're going to write it, it's going to determine what the truth value of the whole formula is. So the question that people commonly have is, well, what order do I do it in? Well, here is a trick. The trick is the order in which you compute or write down the truth value is the order in which you created the formula. So if you're not familiar with that, you should look at formation rules associated with formulas or how to make a well-formed formula. So what's the order in which I would construct this formula? Well, I would start by saying that P is a wolf and Q is a wolf. That would be the first thing I would do. And then I would say, well, if P is a well-formed formula, then not P is a well-formed formula. So we have not P. And then if not P is a well-formed formula and Q is a well-formed formula, then not P and Q is a well-formed formula. So this is the order in which you would construct the formula, and it's the order in which you will assign truth values to the subformulas. We would first start by assigning truth values to P and Q, which we have already done in these columns here. Then we'll move to not P, And then finally, we'll use not P and Q. So with that in mind, let's go ahead and fill out the rest of this truth table. We see that we have P here, and when it's assigned a value of true, what's happening is that this truth value, we are sending it to, let's say, the negation function and saying, well, we have a formula that is true. What does the negation function do to it? Well, it says, if you give me a truth value, the value you give me is true, then I'm going to output or push out a value that's false. In other words, if P is true, then not P will be false here. When we look at row 2, we're going row by row here. Row 2, it says P is true. And so again, we're giving this negation function a value of true as input, and it's going to spit out a truth value. And the value it's going to spit out is the value of false. If you give me true, I'll give you false. If you give me false, I'm going to give you true. That's how this negation function works. So when we get to row 3, we see, okay, now we're giving this negation function the value of false, and so the output will be true. And in the case of row 4, interpretation 4, where P is false, the negation function will say that not P is true. So what we have here under this column right here is we have the truth value of not P. So we've determined not only the truth value of P and Q as well as not P, but now we are going to move on to determining the truth value of the entire formula. So what do we do here? Well, this is another question. Well, which of these truth values do I look at when I'm determining what to write under this caret? We are going to write the truth value underneath this caret to indicate the truth value of the conjunction here. And what we'll look at is the two formulas that the caret connects, the two inputs that it's taking. So we're going to look under the column under the negation as well as Q right there. So we can ignore the truth value assigned to P. What instead is going to the conjunction function is a value of false and true, the value assigned to the not P as well as the value assigned to Q. So we want to focus on those two. When we look at the conjunction function, the conjunction is only going to be true if you give it two truth values. If you give it a false and a true, or a false and a false, or a true and a false, it's going to give you false. So it's only going to be true if there are two true values given to it. So what we have here at row 1 is false and true, and so the result is going to be false. At row 2, or under interpretation 2, we have false and false, and so the result will write false underneath it. Again, the conjunction will only be true if you give it two truth values. And if we give it false and false, it's going to give us false. At row 3, though, we see that we have true and true. This not P is true, and this Q is true, and so the result will be true. And then at row 4, we have true and false, and so the result will be false. So what we have here is a formula, and we have a representation of all the different ways that this formula can be assigned a truth value for each one of these interpretations. So we'd go about reading this and saying something like, well, if we interpreted P and Q as both true, then not P and Q is going to be false here. On the other hand, if we interpreted P as false and Q as true, then not P and Q is going to be true. So this was just one quick example of how you would walk through and do a really simple truth table for a single formula.